Okay, so then talking about the entity relationship model, that's basically the idea is that we're going to take, actually we talked about it, we looked at this picture last time. We have a customer table and a couple of columns to it, an account table that has, these are the meaningful columns to it, and then we're going to have to add extra tables to tie the two tables together. So we're going to use rectangles to represent entity sets, ellipses to represent attributes or columns to those tables. Diamonds will be relationships between the sets. Lines will be links that connect the entities to the entity, connect the relationship to each other. You could have multiple values, so we talked about like you could have multiple cell phones, so multiple email addresses. So we could use double ellipses for multi-valued attributes. We'll use dashed ellipses, so ellipses are those circles for columns, to mean derived attributes. So let me give an example. A derived attribute means it's not actually in the table, but you can calculate it by what's in the table. Like for example, suppose you're driving around in your car in Hackensack, and you want to go to a nearby restaurant. So there's a database that says, the name of the restaurant, hours it opens and closes, and its location. But they're not going to have a column called distance from Hackensack. That's not going to be a column. But on your phone, maybe you can tell where you are, and then they can tell where they are, and then they can do a computation. Pythagorean's theorem, get how far you are from them. And then they can figure out how far you are from them. So we can take a column, and from that we can calculate something else. Another one could be like, let's say you had a column that was had your date of birth, people's date of birth. Well, then you could calculate their age. If you knew what today's date was and the day they were born, you could calculate what their age is. So we're not going to have a column called age, but age could be something we could calculate. It might be something we need, but we're not actually going to have a column for it. So that would be a derived attribute. And then a double line means total participation in the relationship. So we spoke before about we had customers and accounts, and maybe someone wanted to have a rule that says every customer must have at least one account. Why have a customer who doesn't have an account? So then you have a total participation double line. Okay, so now what we have to do is we're designing our table of customers that has a name, social security number, street, and the city. We have accounts that have an account number and a balance, and then we have to somehow tie them together. So what if we did something like this? We have the customer table with the 4 fields, and the account with its 2 fields. Well, these 2 tables are not related to each other. They could have data in it. We could have a bunch of customers and a bunch of accounts, but we have no way of connecting customers to accounts. So one thing we could do is we can add a field. So now we're taking the field Social Security and we're making the assumption that these are all unique values. Every single customer has a unique Social Security number. So with that assumption, we want to program this column to say this must take unique numbers. If somebody ever tried to put in the same Social Security number, the database should reject it, saying I already have that number. So now if we add to every account a Social Security number, what have we effectively done? We've tied every account to a person or a customer by adding this column here. Then we want to have rules on it that say, I only want to accept Social Security numbers that exist in this table. We don't want to have accounts for people who are not customers of our bank. So we now have what we call a one-to-n relationship, meaning every account is tied to one customer. And the way we have this laid out, a customer may have many accounts. Okay, so this would be a one account is, I'm sorry, every account is tied to one customer, but a customer could be tied to many accounts. So that's a one-to-N relationship. What would you think about if we wanted to have a rule that says an account can belong to multiple customers? Maybe like a husband and wife share an account, or a company, a group of people share an account. How could we do that? So how can we have customers are tied to accounts and accounts are tied to customers in such a way that an account can belong to multiple customers?
Then we have to separate the accounts table into two ways. There is individual accounts and multiple accounts.
So,
Multiple people sharing accounts.
would we add another table?
Yes.
Okay, yeah, so one thing we could do is add another table. So we have customers, the way it was before, the 4 customer fields, the 2 account fields. So without this, they're really unrelated. And now we have this table that has customer numbers, account numbers and social security numbers, just mapping them together. So we could have 3 customers mapped to the same account, and we could have 3 accounts mapped to the same customer. So now we could have all different combinations. And there's no rules about the social security numbers have to be unique in this table. They only have to be unique in this table. So now we can just keep adding records to this. So now if you wanted to say, give me all the, if you wanted to ask the database, give me all the accounts related to a particular person, you find that person, get their unique social security number, then go through this table looking for all their accounts, and then take all the account numbers and then start, collecting all the balances. So you can find everything. So this is a relationship where the customer can have many accounts, and accounts can be owned by many customers. So we call this, just to use 2 different letters, we call this an M by N relationship. So customer has an M by N relationship to account in this case. Okay, so these were the symbols we were talking about before. Rectangle is basically a table, we call an entity type. Diamonds are how they're related to each other. The ellipse, we said, was basically columns in the table. If we have the type of a column that we want to be a unique identifier to that table, to any row in that table, we could underline the field and say we're going to call that a key attribute, meaning that's going to be a unique identifier. That would be unique for that row. If we have 2 circles, then that means there could be multiple values. So for example, we could have a cell phone, and we're going to allow ourselves to have many cell phones. We'll probably end up adding a table that says the cell phone and the type of cell phone. We could also have a composite attribute. You could have like customer name, and then maybe that breaks into parts, like first name, middle initial, last name, junior or senior, or something after the name. A derived attribute, this didn't come out too well, but this should be a dotted ellipse. If this was dotted, that would mean a derived attribute, like we could figure out, if we know your date of birth, we can figure out how old you are, something we could derive here. And then relationship where we have a double line means that everything in this column must map to at least one thing in that column. So if we had a rule like every customer must have at least one account, otherwise they can't be a customer. You have a double line. Again, you can't really see this, but that's a 1-to-N relationship. So we could put numbers on here, saying like, it could be 1-to-1, it could be 1-to-N, it could be N-to-N, or N-to-1. To put numbers on those lines to say what the relationships between the 2 are. Okay, so when we go. Yeah, I thought this would come out clear. I want to give, kind of an idea of a database, not too big, not, big enough to get the point across, small enough that it'll be clear, but it's actually not very clear. So maybe I'll have to read some of this to you. But so like here's a table of employees. Employee has a key to it, the employee number. It has the department they're in, the start date, And then there's a relationship actually works for. So some employees could work for other employees. So you can actually have a relationship, a table could have a relationship with itself, which would probably be implemented by having a separate table saying employee and boss or something like that, and then fill in entries in that table. And that's how employees map to themselves. Okay, so then we can have a relationship between customers and employees. Customers have a social security number, which is underlined, so that's their unique identifier. You can have a customer name, customer street, customer city. There's a relationship between customers and a loans table. These are loans, so this was a borrower relationship. So customers relate to the loans table by the borrower relationship. And then we might have rules that say, like, every customer may have a loan or may not. Right? So, like one of you was saying, a customer should always have an account. Well, maybe some of our customers have loans, some of them are depositors, meaning they have an account, and some may have both. You may have a loan and an account with us, with the bank. Every loan is tied to a particular branch of the bank. So this is the type of a bank that has multiple branches. So customers belong to a loan, and the loan belongs to a branch, and then the branch has a city and a state, and then we could have, loans could have payments to them. A payment has a payment number, a payment date, and a payment amount. And we could have multiple payments, that's what the double diamond is, we could have multiple payments for a particular loan. Maybe it's a car loan you pay every month. You could make multiple payments in the same month if you wanted. So it has that kind of a relationship that you could make multiple payments to the same loan. And then we have for deposit, customer could be a depositor, so that ties to an account. There's an account number and a balance. And then maybe accounts split into two types, like a savings account and a checking account. So we could have this triangle thing which says that account, we have maybe a column that says what type of account it is, and then that tells you data in a different table. So what we're basically doing is we are designing a database, initially drawing a picture like this, and there are actually database picture drawing tools. Irwin is a very popular one to draw a picture like this. So you kind of draw this picture, you can then hit a button, and it will create the tables with all these fields in it, and make suggestions of how to join them together. Remember, relationships between tables are implemented by adding either a column to a table or a brand new table that has a column from here and a column from here, and that makes them join together. Depends on how you want them joined together. And it'll make a suggestion for you. You could agree to it, or you could override, the way it was, a suggested way of designing it. Okay. So, yeah, that's all I wanted to say just about this, and about, the database schema design. I wish this was a better picture, but I kind of just described what each thing was. So our idea in generating a database is to have the schema, which is the way the tables are laid out. Then we're going to have to describe how to make queries against the tables. So you might want to have a query that says something like, give me all the customers who have both a loan and an account. Or maybe you want to have, you want a list of all the customers who have just a loan, and maybe send them an advertisement like, hey, why don't you open an account with us? Or maybe anyone who doesn't have a loan, you want to say, hey, why don't you borrow money from us? So you might want to generate a report of different aspects of data in your database. You'd be looking at this picture, and then how the tables were originally laid out would determine how you would write the code to get the query done. So maybe the next topic we'll talk about is how to, once these tables are created, how to make queries against the tables to get reports that we want out of the database.